Hello, we're Team 15 The Wiggles, and our project is a wearable monitor for children on high-frequency ventilation. Every 2.5 seconds, a child is born that will require assistance to start breathing, but for children whose conditions border on the extreme, traditional ventilation is too risky, necessitating a less strenuous alternative. Intro: High-frequency oscillatory ventilation. HFOV is an alternative to traditional ventilation that places less pressure on the lungs through the use of lower tidal volumes. When a child is undergoing HFOV, their chest will shake to indicate that their lungs are perfused. But even with the wiggle present, how can we be so sure that they are receiving enough oxygen? In the past, chest oscillations were measured via a camera-based detection system that was both bulky and exceedingly costly, which is why clinicians currently measure chest wiggle by eye. However, this method is subjective and makes it impossible to evaluate the oscillation frequency with any real precision. Thus, there exists an unmet clinical need for a way to measure and quantify chest oscillations in neonatal or pediatric patients undergoing HFOV in the ICU. To both identify and validate our unmet clinical need, we spoke to both clinicians and researchers and made several on-site visits which allowed us to see the ventilators up close.
Our ethnography supplied us with the knowledge necessary to start drafting up a few designs. To do so, we first had to discern a minimum viable feature set. For our product to carry out its purpose, what must it be able to do? First, it must be able to detect the frequency of the chest wiggle. To achieve this, we used an accelerometer circuit. To demonstrate capability, we hooked it up to a series of LEDs to capture real-time change in movement in each axis. This will allow us to reliably measure chest wall oscillations. The second feature is the adherence of the device to the patient. Skin stretching, perspiration, and wiggling of the chest should not cause the device to move from its place on the skin during ventilation. Our initial hazard analysis helped us identify some concerns to consider for this feature. For example, we were initially considering the use of a band to mount the sensor to the patient. However, the band could restrict movement of the baby, potentially interfering with the life-saving ventilation. Further, the band may restrict sensor movement, leading to signal loss and thus inaccurate readings. We then considered the use of a skin-safe adhesive. It's important to note that baby skin is up to 60% thinner than adult skin and has difficulty retaining moisture. Many adhesives thus pose a serious risk of skin irritation or tearing to babies. However, hydrogel combats these issues. It effectively molds to the skin and adheres strongly, but remains gentle and even helps maintain skin moisture. Now we have to consider how we test our device. Due to many regulations in NICUs and PICUs, we needed to simulate the conditions of the chest wiggle ourselves to test the device. Our current simulation oscillates solenoids to induce a wiggle in a thin foam sheet, as you can see here. Here we will conduct more robust testing by using materials that more effectively mimic a baby's chest and skin. We will refine the shape of the device and look into materials that have comparable properties to baby skin. In spring, we'll move forward with our V&V testing. We will verify that the device functions through further testing, and we will continue to validate with clinicians that the purpose of this device accurately fulfills the unmet need at hand. Thank you.